to catch those up, we are on M, miscellaneous, free response number 13. We just did part B. All right, now this is where it gets to be incredible. This is C. They said G is defined by G of x is equal to the integral from 1 to x of f of t dt. So up until this point, what was f? An original function. With its placement in the integral, what is g? What is f now? A derivative. You see, the first derivative of g is f, and the second derivative of g is what? I guess I should put the x in there. And the second derivative is what? F prime. So with that said, for 0 to 4, find all the values at which g, not f, contains a relative extrema. So now I'm going to do a new number line. Here's my new number line. This is going to be 0, this is 1, this is 2, this is 3, and this is 4. I want to know where g has extrema. What do I look at now? Which one? We have to look at f. Remember I said, isn't it interesting they gave us positive and negative for f? It's like y. This is y. So in between 0 and 1, f is negative, which means g is decreasing. It's positive between 1 and 2, which means g is increasing. It's positive between 2 and 3, which means g is increasing. Negative means g is decreasing. They wanted to know relative extrema. What does that mean? Maximums or minimums. So we would say that g of x has a relative max at x equal 3 and relative min at x equal what? 1, because f of t changes signs. That is the quickest way to say it, the safest way to say it, because if you get your positive to negative, negative to positive mixed up, you'll lose that point. Determine whether g has a relative maximum or minimum and justify. So, all right, let's go back to B. So, how did they award credit on B? If you plotted the points at 0, 1, 2, and 3, did we do that? You got 1 point. Then, the appropriate behavior for the increasing, decreasing, and concave up and concave down is the rest of it. Okay? That is the rest of it. So that's 2 points. Now, a first point for this one, and let me move that. Did we tell them that we know g prime of x equals f of x? That is 1 point right there. Critical points, did we find our critical points? 1 and 3? Yes. And did we answer with a justification? Yes. So you get 1 point for 1 and 3, you get 1 point for saying because f of t changes signs. So then part D is still referring to which function? G. For the first 5 minutes, I'm sitting there and I'm looking at the answer. I'm thinking, there's no way they could get that answer because I was looking at f double prime. What is g double prime? It is f prime. So again, if I look at, this is part D. If I look at 0, 1, 2, 3, 4, I'm looking at now f prime because g double prime is f prime. So when f prime is positive, what is happening? Concave up. Positive, concave up. Negative, concave down, negative, concave down. So there is a point of inflection where? At x equal to, because what changes signs? F prime of x changes signs. So you get 1 point for identifying 2 and 1 point for your answer with justification. That's how they're going to do beasts. Mm-hmm. Okay, so you looked at the graph, which is the first derivative graph of g, and you said at 2 because why? Did you say it? Yes, that would do it. Yes, it would. Excellent, yes. Did you hear that? He said f of x changes from increasing to decreasing. That is correct. And he used his graph, which now is a derivative graph for g. All right, other questions? Yes. Optimization. Let's see if there's an optimization. There might be one in the miscellaneous. And then you justify phi. Or maybe not. Okay, optimization is where you're looking for where is the maximum or absolute minimum. Are you with me, Steve? And when they did that, they gave you either enough information for one equation or two equations. Whatever is to be optimized is what we take the derivative of. If you end up with, let's say, area is equal to length times width with 3 variables, then what they did is they gave you a secondary equation. So you could suppose they said perimeter was 40, and it was a rectangle. So that's when we knew x, oh no, we have length, width and L. How do we do perimeter? 2 L's plus 2 W's is equal to what? P. Then if we solve for L, we'll have 2L is equal to P minus 2W, and then L would equal 1/2 P minus 2W. And that's when we came up here and we put in 1/2 P minus 2W times W. And from there we went to find the first derivative, critical numbers, max and min. So that was optimization. Yes. Well, I mean, I haven't looked through all the questions recently. There very well could be. I just don't have my hands on it. I can't say. Yes. Oh, yeah, slope fields. Let's look at differential equations. So we're going to go to the DE section, and let's look at, we can look at number 4, number 5, number 6, number 7, you name it. What do you want to do? 4 through 7, you pick it. What do you want to do? Okay, we're going to do slope field number 4, DE number 4. All right, so we have, first of all, they told us that dy over dx is equal to y minus 1 quantity squared. This is non-calculator too, cosine pi x. Okay, so they want us to sketch the slope field. So the first thing we're going to look at is what ordered pairs did they give us. They gave us -1, 1, -1, 0, and -1, -1. They gave us 0, 1, 0, 0, and 0, -1. And then they gave us 1, 1, 1, 0, and 1, -1. So now what we're going to do is we're going to substitute all of these into this derivative. Y minus 1 quantity squared times cosine pi x. So if I put y in, what's 1 minus 1? 0. When I multiply 0 by this, do you agree that the slope will be 0? Is that going to be true at every time y is 1? So I know this is 0, and I know this is 0. So now if I put -1, let's put 0 in. That's going to be 0 minus 1 is Negative 1 squared is 1. So I'm not going to worry about this, but I have to put 0 here. So what's cosine 0? 1. So every place I see, so if I put in negative 1, what's cosine negative pi? Negative 1. So that's negative 1. And if I put 0 here, and I put 0 here, this 0 is going to make that 1. What's cosine pi? 1. If I go down here to this 0, and I put 0 in for y, and I put 1 in for x, what is that going to be? That's going to be cosine pi, which is negative 1. So now what are we doing? So now we're going to put in negative 1 here. What's negative 1 minus 1? Negative 2 squared is what? 4. All right, now we're substituting negative 1 in for x. What's cosine negative pi? Negative 1. So that's going to be negative 4. So if we now we're going to put negative 1 in here again. We'll get negative 2 squared is 4, but now I'm putting 0 in. So what's cosine 0? 1, so that'll be positive 4. So now we're going to do negative 1 minus 1 is negative 2 squared is 4, and we're putting in 1. So what's cosine pi? So that's going to be negative 4. So this is what they expect to see. If I have this as my slope field, they expect, I think that's crooked, but I'm sideways. To me, it looks kind of straight. All right, so at negative 1, 1, negative 1 up 1, we have a slope of 0. At negative 1, 0, we have a slope of negative 1, which should basically bisect the quadrants. At negative 1, we should have a very steep slope. So now at 0, 1, we're going to have a slope of 0. At 0, 0, we have a slope at 1, so that basically should bisect the quadrants with a positive slope. At 0, negative 1, I should have a very steep slope in that direction. So now we're going to do 1, 1, I should have a slope of 0. At 1, 0, I should have a slope of negative 1, so we should be bisecting at a negative. And then this is going to be really steep again. So that's going to be negative 4. So when they went to give credit for this, you got 1 point if you had the correct 0 slopes, and you got 1 point for having all your other slopes correct. So if I should have had, along the x-axis, I should have negative, positive, negative, and then I should have negative, positive, negative. So I've gotten 2 points so far. All right, then it says there is a horizontal line with the equation y equals c, and let me get a pen. We've got y equals c, and they said that satisfies the differential equation. What is c? Look at your slope field. If you did it right, it should be very visible. Where's that horizontal line occurring? At 1. So your c is 1. So c equals 1. It is at y equal 1. And now, this is where the lion's share of your points come from. So we're going to take that differential equation, and we've got dy over dx is equal to y minus 1 quantity squared cosine pi x. And this was non-calculator. So the first thing you do, you must separate your variables. So I'm going to multiply by 1 over y minus 1 quantity squared. And then I'm going to multiply this side by dx. If you do not separate your variables, you have lost 6 points. This is one of the problems that you should be really, really clean up on the points. All right. So now we're going to integrate the left and we're going to integrate the right. We need u substitution because there's subtraction in the denominator. So y minus 1 is u. dy equals du. So that means that I can go ahead and make this 1 over u squared du. On this side, because of the pi that's attached to x, I need u substitution here, but I already used u over there, so I'm going to use w over here. So w equals pi x. dw is going to equal pi dx. We're going to solve for dx, so we're going to end up with 1 over pi dw. So I'm going to put my constant on the outside, and now this becomes cosine u du. The issue I've seen recently, at least with my kids, is because there's 1 over, everybody, since we've done logarithms, assumes it's natural log. But it's only natural log if it's 1 over what? U to the what power? First. So what we're going to do here is we're going to rewrite this as u to the negative 2 so that we can integrate this. Integral of cosine is sine. And that's going to be u, and I'm going to put pi x, and what will I have? Plus c. So we got 1 point here for separating our variables. We've gotten 1 point here for a correct antiderivative. We've gotten 1 point here because we remembered our plus c. So now we have to integrate that side. So that's going to be u to the negative 1 times negative 1 equals 1 over pi. This is going to be sine pi x plus c. All right, so this is going to be negative 1 over y minus 1. I've substituted back, and we're here. Now what are we supposed to do? They should have given us something. Did they give us something? They gave us an initial condition, and that initial condition was 1, 0. That means I'm going to put 1 in for x and 0 in for y. You will show this substitution step. Because if you substitute correctly, you have already earned the 5th point. It doesn't, you don't get the 5th point for getting C correct. You get the 5th point because you used the initial condition. So now we have to solve for C. So this is going to be negative 1 over negative 1, which is 1. This is going to be 1 over pi sine pi plus c. So I'm going to have, can I make that pi over pi minus 1 over pi sine pi equals c? So then could I rewrite this as pi minus sine pi over pi? Somehow I don't think it was, what did I do wrong? Was it that complicated? Well, anyway, let's see what happens. I put 1 in for x, and I put 0 in for y, and I got a 1. And, what's sine pi? Yeah, I am being stupid. What is sine pi? It is 0. So, c becomes pi over pi, which is 1. So now we're going to come back up here, and where were we? Yeah, I could have. Yeah, I did this the long way. So I've got negative 1 over y minus 1 is equal to 1 over pi sine pi x plus 1. We still have not earned that 6th point. Because to earn that 6th point, we have to have y equals. Notice it says, find the particular solution, y equals. That was something I didn't know if you got credit for this or not. And when I graded the AP exams, I learned that you didn't. And then I also, the other day saw it says y equals. It should have told me that like 5 years ago. That should have answered my question. So what I'm going to do is I have negative 1. I have, I think I'm going to make this sine pi x over pi plus 1. And what I just did is I multiplied by y minus 1. What are we going to do now? Wow, where did I go? Not where I wanted to be. Where do I go from here? If that's multiply. What does y minus 1 equal? Negative 1 over our sine pi x over pi, and unless I get a common denominator, I'm not going to be able to do anything with that ugliness. However, you can get credit without a common denominator for the ugliness. And my suggestion is, rather than work with an algebraic mistake, just leave it. Now what are you going to do? You're going to add 1. So you would get credit for this answer even though it's ugly, and I would not have given credit in the classroom. That is your 6th point. Copy error, I did a copy error. Plus, actually that was more of an algebra error. I didn't get that point. I lost that point. Okay, that's a differential equation. Yes? Which one? Wait a minute, I am on, oh. Is that, what is that? The next one. Number 5? Number 3. Okay, going back the other way. All right, so yes. Yep. So let's start a new page. Notice there's no slope field. Slope fields were relatively new in about 1908, 2007-ish, 2008-ish. It says, at the beginning of 2010, a landfill contained 1,400 tons of waste. That is at T equals 0. That is an initial condition. That is important. Okay? The increasing function, W, is increasing. What does that mean? If W is increasing. Someone in here can tell me. W is increasing. What does that mean? W prime is greater than 0. Okay? So, and it models, by the way, the total amount of solid waste stored at a landfill. Planners estimate that W will satisfy the differential equation. So dW over dt, which is W prime, is equal to 1 over 25 times W minus 300. And this is good for the next 20 years. So there's a closed interval. So now it says W is measured in tons, T is measured in years from the start of 2010. So 2010 is T equals 0. So if they want to know what year, you're going to need that information. Use the line tangent to the graph. Okay, tangent line. How do I get a tangent line? What two things do I need for a tangent line? Slope and point. All right. They want the tangent line, use a line tangent to the graph of W at T equals 0. What's the ordered pair? What's my point? It is 0 times 0, 1,400. Now, how do I find my waste? How do I find W? I wonder, how do I find my W? My slope. Using the differential equation. So what is my W? So my slope is going to be 125 times 1,400 minus 300. Or 1 over 25, I think that's times 1,100. How many quarters are in $11? 44? I believe that equals 44. So if I wanted to write the tangent line equation, okay, let me go back. I want the tangent line to the graph of W. So the tangent line, I'm going to go ahead and let be y, is equal to, nope, I'm not going to do it that way. We're going to say y minus what? Y minus 1,400 is equal to slope times x minus 0. And you stop there. Don't simplify, you've got the point. So dW over dt at t equals 0. Did we find the derivative at t equals 0? Did we? Yes. We got 1 point for that. Did we get 1 point? We got the tangent line, but then it says use it to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, and they were very sweet on telling us that T equals 1/4. So what do we do now? Oh, okay, let's go back. What should I not have here? What should that be? That should be a T. So what am I going to do? I'm going to put T in there. So I'm going to have y is equal to 44 times 1/4 plus 1,400. I believe that's 11 plus 1,400, or 1411. And that would be 1411. This is a tangent line equation, and that would be tons, because I'm approximating W. not dw. So we have this curve, we have this tangent line, and I'm going over here, and I'm using this tangent line to approximate the actual y value. So that is going to be in tons. So now it says find the second derivative. So we need a second derivative. Question is this product rule? Yes or no, and why? There's multiply. The check for product rule, are there variables on both sides? No, therefore it is not. So d2w, that's how we do this notation for second derivative, is equal to 1/25. All right, what's the derivative of w? 1. What did you just do? The derivative of w with respect to what? Time. That's what everybody forgets. And what's the derivative of 300? It is going to be 0. Now, they said in terms of w. Right now, this is in terms of dw over dt. Do we have a substitution for dw over dt? So what we're going to do is we're going to take this, and our d2w over dt2 is going to be 1/25 times, and we're substituting our 1/25 w minus 300. And I think, and you can leave it that way. So did I find it in terms of w? Yes. So finding this derivative was worth 1 point. Now, determine whether your answer in part A, which is up here, my 1411, is an underestimate or an overestimate of the solid waste of the landfill. What did they tell us about W in the beginning? They said W is increasing. So what did they want? Did they give us a time? At time equal 1/4. What will the second derivative tell us? When I substitute something into the second derivative, what does it tell me? Minimum, maximum of first derivative, or concavity of original. So if I put 1/4 in, so we're going to do d2w over dt2 at t equal 1/4. This is going to be 1/625 times 1/4. Oh, wait a minute. Hold on. What was the w at 1/4? 1411. Why do I not substitute 1/4? Because that's time, and we want w. So we're going to have 1411 minus 300. The only thing I really need here, is that going to be positive or negative? When the second derivative is positive, what's the concavity? Up. They said w is increasing, w is concave up. So the increasing part of concave up is here. You with me? Now, our tangent line is tangent to this curve. So when I estimate on this tangent line, is that y value an overestimate or underestimate of the y value it's actually predicting? It's an underestimate. Why? Because second derivative of w is positive and w is increasing. That would be your justification. So you get one answer then for your reason. It's an underestimate because the second derivative is positive. And I guess the fact that because they gave us this, saying that the second derivative is positive is sufficient enough for the credit. All right, then it says find a particular solution. So that takes us back into separation of variables. So we have dw over dt is equal to 1/25 w minus 300. So if we separate these variables, it's going to be dw, and I'm going to divide or multiply by the reciprocal. That's a big fraction. All right, is equal to 1/25 dt. So I've gotten my first point for separation of variables. This side is easy to integrate. It's going to be 1/25t plus c. I've gotten my point for my plus c, my point for separation of variables. The antiderivatives for this together are worth 1. So we'll say u is equal to w minus 30. So du is equal to w. That should be dw. So now this is going to be the integral of 1 over u du is equal to 1/25th t plus c. All right, what is the integral now of 1 over u? Natural log of the absolute value of u, which was w minus 30, is equal 1/25th t plus c. All right, they gave us the initial condition of 0, 1400. I am 1400. So I think I am going to take this into exponential form first. So how do I get this into exponential form? E raised to the 1/25th t plus c is equal to what? W minus 300. How do we treat this? Do you all know? I know my kids know. Okay, in case you're shaky, that's e to the 1/25th t times e to the c, because when you multiply, you add exponents. And if you take e and raise it to an unknown number, we'll call it sub 1, then I'm going to get just a new unknown number, which is ce to the 1/25th t is equal to w minus 300. So now what are we going to do with this ordered pair? We're going to put 0 in for t. What's anything to the 0 power? So that means we have c is equal to 1400 minus 300, which is 1100. So again, because we got this and this correct, that was our fourth point. No, that was our third point. Substituting in our 0, 1400 gave us another point, and then going back and saying 1100 e to the 1/25th t equals, oh no, I'm going to say plus 300 equals w is our final point. Yes. M number 5. Say that again. M number 5b. All right, we're miscellaneous. We're at question number 5 in our miscellaneous, and we want part B. All right, so this is one of the ways that they do implicit differentiation on the free response. Consider the curve, show that, so you know what your answer should look like. So that's implicit differentiation. They're going to check the work. So part B says, show that there's a point P with an x-coordinate of 3 at which the line tangent to the curve at P is horizontal. So what does that mean? If we have a horizontal tangent line, what do we know about the derivative? So in other words, dy over dx has to equal 0. Well, dy over dx happens to be 3y minus 2x over 8y minus 3x. So if I wanted to solve this, can I use a proportion? So this is going to be 0 equals 3y minus 2x. So now, didn't they tell us when this was happening? Show that there's a point P with an x-coordinate 3 at which the line tangent to the curve is horizontal. So at this point, when x equals 3, do you agree that this equation becomes 3y minus 6? So 6 equals 3y, or y equals 2. So we've got, 3, 2. Now, don't assume this works. We found a 3, 2, but where should it work? In your original equation. So we have x squared plus 4y squared equals 7. I used to get all excited that I got an ordered pair and think I was done when I wasn't. So this point should satisfy this equation. So what we're going to do is we're going to put 3 in for x and square it. We're going to put 2 in for y and square it. Then we're going to put, oh, that's an equal sign. Then we're going to put in our x, which is 3, and our y, which is 2. So I've got 9 plus 16 equals 7 plus 9 times 2 is 18. 9 plus 16 is 25 equals 25. So it is a point on my curve, and we did show that the derivative was equal to 0. So setting the derivative equal to 0. For those who are not mine, I've hit this really hard for mine. Anytime you're finding a critical number, you must show the derivative equals 0. You literally get a point just for this. Similarly, you lose a point for not showing that. Okay? That's really important. Whenever you're looking for a critical number where the derivative equals 0, you either say y prime equals 0, dw over dt equals 0, or in this case, take what the derivative was and set it equal to 0. You've got to set the derivative equal to 0 because that's more points more recently than not. All right, showing that the slope is 0 at 3, 2, that means all of this work gave you a second point. And then showing that it truly is on the curve is your third point. So that was 5 points. So you wanted B, nothing else? Okay, next question. Oh, sure. Yes. Negative x squared, that's negative 1 times x squared. So the 1 is, that negative is not being squared. Okay? That is a common error, squaring the negative. Yes. Multiple choice, page 23. Multiple choice, page 23, and it's number 85. Okay, so let's go to a new page. This is multiple choice, page 23, and this is number 85. We have a table that shows the f values or the y values and the derivatives. So it says a table gives values of function f and its derivative at its selected values. The derivative is continuous. Oh, I love this one. Okay, this is that second fundamental theorem of calculus. So we're integrating from negative 4 to negative 1 of f prime of t. All right, when you integrate f prime, where does it take you? Which is f, right? It's going to be f of t, evaluated from negative 4 to negative 1. What do you do when you have this situation? When you have these? How do we evaluate that? F of negative 1 minus f of negative 4. Now go to your table. What is f of negative 1? Negative 1.5 minus f of negative 4, which is 0.75. Why do you think they gave you the bottom part? To see if you knew what you were doing. So whatever that is, I think that is going to be negative 2.5, negative 2.25. So that's that second fundamental, or that's a fundamental theorem of calculus. So when you have a table, think, I love this now. It used to stump me, but I think these are so cool. Other questions? Okay, while you're looking for one, let's go to tables. Because I have not done hardly anything with my kids on tables. All right? You all should have had more work because he had you for 30, well, maybe 25 days of review, and I had mine for what, 3 sessions, which is like 6 days. So, yeah, it's like, all right, so let's see. Let me pick it. So either 8, 9, or 10, I don't care. Okay, 9. This is one of the more recent ones. So if we look at number 9, this is a table. They've given us f of x, they've given us f prime, they've given us g of x, they've given us g prime, and all sorts of stuff. Twice differentiable functions f and g. That means there are no sharp terms. Okay? Twice differentiable means no sharp terms. Define for all real numbers x. So there's the values given. Find the x coordinate of each relative minimum of f. If I want a minimum on f, what do I have to look at? We're on tables. The table, the T, what T? I don't have my page number. It's T9, problem 11. T11, problem 9. Okay. So, all right, so if I'm looking for a minimum or a maximum, and I'm looking for a minimum and maximum on f, that means I have to look at f prime. So we've got -2 on the left, we've got 3 on the right, and it looks like we have a -1 and a +1. So we're going to look at the f prime row. It says from -2 to -1, negative, which means decreasing. -1 to 1 is negative, means decreasing. And then 1 to 3 is positive, meaning increasing. Where is the relative minimum? X equal 1. Why? Which f prime changes signs. So we got 1 point for our answer and justification. Now, explain why there must be a value c between -1 and 1, for which the second derivative at c equals 0. All right, it says explain why there must be a c. That is a theorem. Which theorem do you think it's going to be? Mean value theorem. Okay? So we need a mean value theorem. Explain why there must be a value c from -1 to 1 such that the second derivative of c is equal to 0. All right. So if we look at part B, this is part B. We know the first derivative is differentiable, correct? We know it's continuous. Did they give us ordered pairs? The first derivative ordered pairs are -1, 0 and 1, 0. You see, they gave us the slope of the tangent line. What are we looking for? Slope of the secant line. So we're going to say 0 minus 0 over 1 minus a -1 equals 0 over 2, which is 0. So, yes, this is true. You have to show this, that you understand what's going on, and this is by the mean value theorem. If you don't remember the name of the theorem, what do you say? The function is, or f, because f prime, f double prime, f, you can say them all, is continuous. No. Just because a function is differentiable doesn't mean that you're going to specifically have a second derivative that's 0. Tangent line, yes. And that's what the slope of the secant line. Part C says the function h defined by, all right. C we have h is now going to be natural log of f of x. Find h prime of 3. Ooh, of 3. All right. So what does this tell me I am supposed to do first? What does that tell me I should be doing? The derivative. Okay, so we're going to do the derivative of h. So h prime is going to equal, how do we do the derivative of a natural log? 1 over the function times the derivative of the function. So when I first started doing this sort of thing, I would say, you know what, I really don't have a clue as to what I'm supposed to do, but I do know that that says take the derivative. So once I get this far, it's like, oh, well, now what does that tell me to do? Well, that means to replace 3 in the derivative. So now this becomes 1 over f of 3 times f prime of 3. Well, let's look in our table. Do you know what f of 3 is? What is it? 7. All right, so that's going to be 1 over 7. What's the derivative at 3? Of f. What is it? It's a half. So this is going to be 1/14. Did I show the computations that led to my answer? Yes, I did. So now, let's look at this one. This says we are at -3, no, we're at -2 to 3, and we're supposed to integrate f prime of g of x times g prime of x, dx. How do we unravel that one? This is a derivative. What is it that, what rule do you think they use to get that derivative? Chain rule. They use chain rule. So what do you think this was before? That's the derivative of the outside, so it had to be f, and there's your inside. So this derivative right here, or this integral, I should say, is equal to f of g of x. Now, what are we supposed to do? Evaluate it from -2 to 3. We're back to the problem you just asked about on 85. So now what we're going to do is we're going to substitute. So we're going to have f of g of 3 minus f of g of -2. Look at your table. What is g of 3? 1. What is g of -2? So this is going to be f of -1. Now what is f of 1? What is f of -1? So that's going to be -6. Let's do another table. Let's do number 8. I'm not sure how you would unravel that other than, no, I don't think you can. Okay, so we're going to look at number 8. Hot water is dripping through a coffee maker, filling a large cup with coffee. I graded this one several years ago. So we are filling a cup. What can you tell me about the function we're going to be doing if it's filling? It's going to be increasing, correct. The amount of coffee in the cup from 0 to 6, that's a closed interval, and there's probably theorems here somewhere, is given by differentiable. What does differentiable tell me? Continuous and no sharp turns. You can take the derivative. So we know it's continuous and there's no sharp turns. So what is this, an original table, a first derivative table, or a second derivative table? When in doubt, look at units. It's an original because it's ounces. It should be a derivative. It has to be ounces per time. C of t, okay, t is measured in minutes. Selected values of c are given. Use data in the table. When they say use data in the table, they aren't kidding. All right? So let's go and do this. So if I want to approximate the derivative at 3.5, what points am I going to be looking at? We're going to look between at the 3 and the 4. Correct. So we're going to do 12.8 minus 11.2 all over 4 minus 3. And what are the units for this? Ounces per what? Well, it's a first derivative. And c is not a derivative. So that is just going to be ounces. All right, I don't know if Mr. Southard told you that. You get credit right now for what you have. If you subtract this and make a mistake, you just lost a point you earned. Is that crazy? Don't simplify it. Leave it. Let me give you another little tidbit. Let's pretend you had no clue how to do that, but you did know the units. You did know it was ounces per minute. One person did ounces per minute. Because you see, you get 1 point for the answer and 1 point for the units on this problem. Another person made up a number. 4 ounces per minute. This person did not get the units point. This person did get the units point. So in order to get the units point, what do you need to have? A number with it. Is that amazing? Little? These are insights. All right, so we just got 2 points for the first part. Second part. It says, is there a time t between 2 and 4? Is there a time t where c prime is of 2? Is it c prime? No. C prime of t is equal to 2. What is this? It is mean value theorem. And they gave you the derivative. You have to find the what? You have to find where there is a spot where there is a algebra 1 slope that is 2. So you got to start looking to see where this might be happening. We know it's not between 3 and 4 because we just did that one, didn't we? Between 2 and 4. If we have 12.8 minus 8.8, what do you get? Oh my gosh, look at that. See, I'm making it hard on myself. I was looking at the whole table. So they've given us this closed interval. So if I'm going to do anything, I'm going to do the slope between those 2 points because it should be the slope of the secant line. So that means that I'm going to do 12.8 minus 8.8 over 4 subtract 2. And that is going to, you really need to know whether or not that is 2. Is that 2? So you would say yes by MVT. And if you don't remember MVT, what do you say? Because a function is continuous. All right, bothers me that they give credit for that, but it's their game, it's their party, we play by their rules. All right, you must show this. That's worth 1 point. The conclusion, yes, and MVT is your second point. So let's read on. It says, and the table. On the table, do you like Riemann sums? Oh, you almost guaranteed a Riemann sum on a table. So it says, use a midpoint sum, 3 subintervals of equal length indicated by the data in the table to approximate. So now you got to pay attention to your integral. First of all, it is 1/6 from 0 to 6. Everybody forgets the 1/6. They get so excited that they've done the, what do I want to call it, the Riemann sum. All right, so for me to do a Riemann sum, I just kind of draw a curve, and this is my x-axis, and that does not look very parallel, but it might be to you all. And how many numbers? 1, 0 through 6. So I've got 0, I've got 1, 2, 3, 4, oh, I'm running out of room, 5, and this will be 6. So we have to do midpoints. So it is going to take 2 of these rectangles to make a midpoint. Are you with me? Do I have the 3 subintervals they requested? Yes. This was 0, 1, 2, 3, 4, 5, 6. What is the width of that rectangle? And the width of this rectangle? And the width of this rectangle? We're not going to multiply by the left. We're not going to multiply by the right. We're going to multiply by the part that's in the center, which is 5.3 and 11.2 and 13.8. So we would say 1/6 of 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8. This gives you get 1 point for the midpoint sum, that's this part in here. You get 1 point for the approximation, which is also is 1/6 of this. And we can stop here. You've already earned the points. You don't need to do the arithmetic. If you do the arithmetic and you make a mistake, you have lost 1 of the 2 points you just earned. And then we're going to interpret this. What does this mean? This is 1/6 of 0 to 6. And what did we do? We did C of t, correct? What does C of t represent? Ounces. What does dt represent? Time in minutes. Have you ever multiplied ounces times minutes? It makes absolutely no sense. But remember, we have the 1/6 out front, and that was 0 to 6 minutes. That 1/6, the 6 in the denominator, introduces minutes back into the equation. So what did we just find? We found the average number of ounces in, was it the coffee cup? No, average number of ounces of coffee in the cup, or is it in the cup on the interval, over the interval 0 to 6. Average number of ounces over the interval 0 to 6. We could do minutes here if you wanted to, because that is a time interval. So in order to get credit for this interpretation, you had to have average. Oh, that is not a highlighter. Let me start over. You had to have average. You had to have the time interval. And you had to have ounces. It's the average number of ounces in the cup. The average amount of coffee in the cup. And I would say that if we had started with it, it would have been the average number of ounces added to the cup. So they, I think, would have given you credit for that. Because if we had started with something else, let's say it was already 2 ounces in the cup, this would be what was added. Not the average in the cup, but because the cup was empty to start, it would be in the cup. All right, part D, the amount of coffee in the cup in ounces is modeled by. Okay, so now we have a function. So our function is b of t is equal to 16 minus 16e to the negative, oh, I remember grading this. All right, so this is ounces. This is original. This is not a derivative. Using this model, find the rate. So what does that mean? Rate. Derivative. So we need the derivative at t. Let's see. Using the model, find the rate at which the coffee in the cup is changing when t equals 5. So the first thing you have to do is the derivative. So what's the derivative of 16? 0. So that's going to be negative 16 times ln of the base times the function as it appears times the derivative of the exponent. So that b prime of t is equal to negative 16 e to the negative 0.4 t times negative 0.4. You have credit already. You mess up multiplying negative 0.4 times 16, you've lost the point you just earned. And a lot of kids did that. So that wasn't enough, though. They want specifically at what? 5. So you have to show them that you are using the derivative. If you do not show, it says using this model, fine. You've got to show the substitution. Negative 16e to the negative 0.4 times 5 times negative 0.4. Have you just earned that 0.2? Yeah, you have. Is it getting easier? Is this a calculator question? It was not in 2013. No, even on a calculator question. Well, I mean, you could push the buttons. That would be safer than this. But this was non-calculator, so you had to be careful. So on these tables, you will be doing Riemann sums. You can almost, and average slope, your algebra 1 slope. Oh yeah, let's do some PMs. What PMs do you want to do? That's a biggie on the test. That's a major, major concept. If particle in motion, I would say let's look at the more recent ones. Okay, And the more recent ones would be something, would be possibly 2. Let me see if we can get better. This was my goal one year, was to increase my particle in motion score, so I put tons in here. Okay, number 16 would be good. Number 16 would probably be the best because, or numbers 15 or number 16, because that was 2013 and 2014. What do you want to do? 15, all right. This is number 15, 2015 or number 15? Number 15, all right. So let's go to a new page. This is PM page what? Page 17, this is PM question number 15. Particle moves along a straight line. All right, so that doesn't tell me whether it's left, right, up, or down, does it? If it says x-axis, you know it's horizontal. If it says y-axis, you know it's vertical. We're 0 to 5, which is a closed interval, which means we could have theorems. Velocity. What do we know about velocity? It gives direction. It gives speed. It's a first derivative, which gives me increasing, decreasing by positive, negativeness of a position. What else does it give us? Max and mins. All right. Did he teach you how to read these? To highlight and ask yourself what's going on? Okay. So I'm modeling that for you right now. Is given by, so this is our velocity function. It is a first derivative. And this is important, especially because if you've noticed on the AP exam, lots of derivatives have no primes. And we get so used to having the primes that we think that these are original. But velocity, you all probably wouldn't have. Plus 3t to the 6/5. This was a calculator one, I do believe. Does it say calculator on yours? Okay. So there's our velocity. Oh, and the position of the particle, our position is s of t, by the way. It is known that at time equals 0, it was at 10. This is an initial position. This is going to play in. Those little things right there are the ones I used to miss before I learned how to read these well. It says find all values of t. So part A, we're looking for time, and it looks like there might all values of t is probably going to be an interval between 2 and 4. So I'm not going to use all of 5. It's only going to be 2 and 4, for which the speed of the particle is, what did I just do? The speed of the particle is 2. Are you aware? To figure out whether the speed, we just need speed, correct? We want the speed, let's see, find all values of t for which the speed of the particle is 2. So we're going to go to our calculator since this is a calculator one. Oh, I just closed it, darn it. I have to open it up again. All right, I want that one. And we want it on top, or it'll go away. All right, so we're ready. So we got a calculator. So we want to find all values where the velocity is 2. V of t, the speed. The speed is 2. Now, what is speed? Absolute value of velocity. So another way of saying this is where the absolute value of velocity equals 2. I graded this one too. All right, so let's turn this on. Let's go to y equals. So what we're going to put in y equals, you know where absolute value is on your calculator? You're going to go to math. You're going to go over to number. And the very top ABS is absolute value. So we're going to do absolute value of our function, which is -2. We're going to add to that, come on, we're going to add, wrong parenthesis, we are going to add t squared, which would be variable squared, plus 3 times the variable, and that's going to be raised, and I'm going to put this in parentheses, otherwise it's going to raise it to the 6th power and then divide the whole thing by 5. So 6/5 power. Was there more to it? Yes. And then we're going to subtract t cubed. So that would be x raised to the 3rd. Let me go back up here. Let me go down in there. So what am I looking at? Just what? 2 to what? 4. So all I want to do is look at 2 to 4. I don't want to cloud my thinking with anything else. You with me? So this is a velocity graph, correct? And we want speed. So the question is, this is the speed graph, but we want to know when is it 2. So what am I going to look at for this? I need to find out when it is equal to 2. So I need to know when the speed is 2. So I'm going to come back up here, I think, and I'm going to enter 2 and see what happens. Okay, pardon? Okay, so I need a y value that's 2. This is all my y values that are 2. Do you see that I have 2 of them? You with me, or did I lose you all? Did you? I don't know. I did 0 to 2. I think took my window 2 to 4. Did you do your window 2 to 4? Oh, did you do absolute value? I hit graph. Let me see what you have up in there. You probably have a fancier calculator than I do. All right. So you have negative, I don't think you did absolute value. Oh, got it. Okay. See, yours is much fancier than mine. You did your 6/5, you did your x squared, you did your 3t. Oh, but the minus x cubed is still in your exponent. So you forgot to, yeah, that should be deleted. And I don't know if your calculator would be mad about that. Yeah, you got to move that down. Now, okay, so do you know how we're going to find those 2 points? We're going to do second trace, which is calculate. We're going to choose 5 because that's intersect. So we want the point of intersection. So we want to get the cursor close to the point. Am I close to my first point of intersection? So I'm going to hit enter. My second point, it's close, and I'm not going to guess. And this is going to be at t equal 3.127629. And we could round that. If you give them all of this, we stop reading after 2, and you would get credit. Okay? So now we're going to go to the second one, and we're going to have second trace, and we're going to do 5, and we're going to go over here. We're going to go over here to this one, and we're going to hit enter, enter, enter. And my second time is 3.473402. So you needed to show them that this gave you 1 point, and then having these 2 answers gave you the second point. They have to be, they gave you credit for 3.127 or 3.128. They gave you credit for 3.473 or, yeah, because, and again, if you write all those digits, let's say you are correct to here, and those are wrong, we don't see those. We don't look at those, we don't consider those. So yes, we will stop looking at 3 digits. So that's why they allowed 3.127 or 3.128. Okay? All right. So now it says write an expression involving an integral. So we know we have to integrate. It's an expression. They didn't say an equation, though maybe we will, that gives the position s of t. So how am I going to get s of t? So part B, let me change colors. We're going to have S of t is going to be, now we want position. What do we have to think about? The initial condition. We started at 10 and then we did heaven only knows what from 0. Now wait a minute. It says gives an expression, gives you a position. So I'm going to have to use an x up here because they didn't tell me where. You with me? And I'm going to do v of t dt. There's my integral expression. Then they said, using this expression, find the position at 5. So now I'm going to do s of 5, and we're going to have 10 plus the integral from 0 to 5 of v of t dt. And you're going to do that on your calculators, because this was a calculator one. Okay? And we take off the absolute value to do that. Are you good with this? So you needed the expression 0 to x, 10 plus to get that point. Now it says find all times t from 0 to 5 when the particle changes direction. How do we know when the particle changes direction? Velocity equals 0. So I'm going to turn my calculator back on. Do you know, if I come over here and go to that equal sign and hit enter, when I go back up, oh darn, and let me do this again, and I hit enter and hit enter it, well, notice that it's not dark anymore. It won't graph it. Did you all know that? Okay. So if I look at this, I don't want absolute value anymore. I need velocity. So I can delete this. I'm afraid that if you have a fancier calculator, you're going to have to retype it. So if you have a fancier calculator than I do, one option of what you could have done initially is you could have typed in this equation in y1 without the absolute value, and then you could have come down here and you could have gone to math. You could have gone over to number. You could have done absolute value, and then if you press alpha trace, it won't work on mine. If you press alpha trace, you will get these options. I have to do this. And then I will type in y1. Now this says take the absolute value of y1. And then I would turn off that function. So I could have used, both of them if you have that one. So I'm going to turn this one off because I don't need it. So now I have to change my window because now we want to look from 0 to 5. So if I look 0 to 5, how many times does it happen? Twice. We have to find those. When I go to second trace, what do I choose? Which one? No. I'm going to have to choose 0 because we're looking for at the x-axis. Now I find this very tedious to move my cursor. So it's asking me for a left bound, and I know that 0 is to the left, so I'm typing it in. I know that this is 2 is to the right, so I'm going to type it in. I'm not going to guess, and I'm going to get something if I hit this hard enough. All right. So I know that one of my times is 5.53603315, and I'm going to, just in case, I'm going to let the AP people know that I'm calling that A. And then I'm going to take a moment to second quit, and I'm going to store this in alpha A. So I'm going to come back here. I'm going to get my next one by choosing 0. I know that 2 is to the left this time, and I know that if this was 5, I've got 4 to the right, and I've got my next time, which is 3.31776563, and that is B. I'm storing that in B. So before I get talking and not do this, this is second, stop, store, alpha, B. Enter. All right. AB. So now it says, let's see, find all times, justify your answer. So the particle changes direction. Well, let's go back and look. The particle, we know that particle changes directions Okay, particle changes directions, and you would write out changes. And I'm going to say at t equal a and b, so I don't have to rewrite those, because the velocity function changes signs. And you've nailed it. You could say at 0.53 because the velocity went from negative to positive, and at 3.317 because the velocity went from positive to negative, but if you mess those positive negatives up, you won't get the credit. Changes signs gives you the credit, and you don't take that risk. Yes?
Could you just put an at sign in front of the two answers rather than calling it A and B, and then put to the right of that B of T change?
Okay, so now is the speed of the particle increasing or decreasing at t equal 4? To get speed increasing or decreasing, what must be true? That's Ruby. Hi, Ruby. We're going to be out of here by 5. It's kind of reminiscent, isn't it? Okay, thanks. Okay, she's the best. So acceleration and velocity have same sign, you're increasing. Acceleration and velocity different signs, you are decreasing. Are you aware of that? Okay, you have to be specific though, otherwise you're giving them a rule. So you are going to say that v of 4. So let's go back to our graph. V of 4 on. 1, 2, 3. There's V of 4. What is V of 4? Positive or negative? Negative. So we're going to say V of 4 is less than 0. Now, what else could you have done? You could have said second trace. You could have gone to value. You could have typed in 4, and it would have given you its y value, maybe negative. And you could write negative 11 if you want. V of 4 equals negative 11.47576. Then you're going to need A of 4. So how do we do that without having to do the derivative? We choose number 6. So we're going to choose 6, and we're doing it at 4, and that derivative or that acceleration is negative 22.29572. So we are going to say that the speed is increasing because if you say velocity and acceleration have the same sign, you don't get that credit because it's a rule. If you say V of t and A of t are both increasing, you still don't get the credit because it is a rule. Make it specific to the problem because V of 4 and A of 4 are both negative. Who would have known? No. We cannot say they are the same signs. Oh, you could say V of 4 and A of 4 are the same sign. Why is that? Why will they give credit on that? What's specific? You've got the 4. Exactly. A of 4, that is the derivative of velocity, correct? Okay, so let's go back to your graph. Remember, what kind of graph is this? It's the velocity. So we need the derivative of velocity. So if you go to second trace, look at number 6. What is that? Yeah, you hit number 6. And what specific number do you want? 4. Type in 4. Enter. Boom. All right. So let's see. What other tidbits can I give them? Yes. Okay, go through the differentiation rules. Sure. Okay, so this is important. Let me get rid of the calculator. All right, So how do we do the derivative? The derivative of a natural log, and I give you one and one only, so it's going to be the natural log of a function, period. I'm not going to do natural log of x because that's just a special case. This is always going to be 1 over the function, there is no ln here, times the derivative of the function. Now, if you have an log of some base of a function, you are going to take that through the change of base. In other words, this is going to become the derivative of, to do change of base, it's going to be, let's go ahead and let's make that, it's going to be 1 over ln of this base right there times natural log of the function. That's how we go through a change of base. So we're not going to leave it as a logarithm. We're going to change it to a natural logarithm because we know how to do that derivative. I want to impress upon you that this is a constant. It is not a variable. Okay? So now this would then be 1 over ln b times 1 over the function again. We're using the same rules as above as the derivative of the function. But remember, when you're doing derivatives of logarithms of any type, what do you always do first? Properties, properties, properties. Okay, I did years where I didn't remember that. In other words, if I have the natural log of x squared minus 3 over 2x plus 4, you are not going to do the derivative right now, because this is the same thing as the natural log of x squared minus 3 minus the natural log of 2x plus 4. Now you are going to do the derivative. So if I were to do the derivative now, this is going to be 1 over x squared minus 3 times the derivative of that, which is 2x, minus 1 over 2x plus 4 times the derivative of that. So you've got 2x over x squared minus 3 minus 2 over 2x plus 4. If you didn't do that, then this would be 1 over this awful, ugly-looking fraction. And then when you go to do the derivative, you're in quotient rule. This is working smart. That's working hard. And I worked hard for an awful lot of years because I did not remember properties. The parentheses, when I split it, you mean here? I always just put it around there so I remember it's all together. No. Okay, so that's logarithms, exponentials. When you're taking the derivative of an exponential, and now this is for any exponential, so I don't care what the base is. It's a number raised to a function. Whether it's e, whether it's 2, whether it's 3, the derivative of this is going to be natural log of the base times, and I like to put this in parentheses, the function just as it appeared, times the derivative of the exponent. So if we want to take the derivative of e to the square root of x, that would be natural log of e times e to the square root of x times the derivative, basically, of x to the 1/2, which is 1/2 x to the negative 1/2. So that's 1. So you're going to have e to the square root of x over 2 square root of x. Now we're going to do one that's not an e to show you that it works for everything. So if we do one that's not an e, we're going to do, where are we? Derivative of, let's say, 7 raised to the x squared plus 3. So it's going to be ln of the base times the function as it appears times the derivative of the exponent. That's about as good as it gets. Nothing simplifies. The reason why I put this in parentheses is so often if I have 2 times this, guess what kids want to do? And if you have that in parentheses, you are less likely to make that happen, make that mistake. Other questions? wait a minute, no. If you have an integral that has a natural log like that in it, okay, it's going to be u substitution, and u will be the natural log. What we learned was we learned the integral of 1 over x dx is natural log of the absolute value of x plus c. So when we integrated, we get a natural log. You never learned this. But you did have integrals with this in it. That means your u substitution, u will be that natural log because you don't know how to do it. Mm-hmm.
In the books or on the website where I can find the full comprehensive list of all of the trig derivatives and integrals?
Trig derivatives and integrals, they should be in your book. But you could put down derivatives, like maybe reference sheet for derivatives. Let's look on your course objectives in the beginning. If you look at OR 9, there are your derivatives for the sines, cosines, tangents, e's, a's, l's, exponential, logs, arc sines. We didn't get there. Sorry, we didn't have enough time. If we look at OR 11, there's a lot of integrals there. If you do, it's going to be one question. It wasn't worth the time. Reviewing was more valuable than taking 2 days to do that, or a whole session. Other questions? I'm here tomorrow too. Okay, let me also direct you to a page in the OR that is a great summary. First of all, OR 12 has all your different definitions of derivatives. OR 14 goes through some of your intermediate value theorems, your theorems, and second fundamental theorem of calculus. It's OR 14. How many OR 14s do you have? I have 2 OR 14s. Okay, so the second one, do you see where it says graphing? All right, so it says F. F is increasing. F is increasing, decreasing if the first derivative is positive, negative. All right? At point C, F has a local maximum, and there it says F prime of C is either 0 or undefined, and F prime changes from positive to negative at this point. Was this what you're asking me? Okay. Let's go one step further to F double prime. When F double prime is, this is your second derivative test for extrema. The second derivative test for extrema said if you have F double prime of 4 equals negative 8, the fact that it's negative means that it's on a concave down region. You had to have known that F prime of 4 was equal to 0. That was important. That means it's a critical number. Then you know it's a maximum. That's your second derivative test for extrema. That's what that third column is on the second row. You have to first establish that it's a critical number. And then it shows you a local minimum. So if you want to know when F is increasing or decreasing, it's all about the first derivative being positive or negative. If you want to know the maximums, minimums on F, it's all about where F prime changes signs from positive, negative, or negative to positive. If you want to know where F is concave up or concave down, it's about where the first derivative is either increasing or decreasing, concave up, increasing, concave down, decreasing, or where your second derivative is positive, negative. So if your second derivative is positive, the original is concave up, second derivative negative, concave down. And then your points of inflection are based on your concavity. Other questions? Which one? M14. Miscellaneous number 14. Grass clippings. They decompose. All right. They're in a bin and they're decomposing. So what do we know about what's happening in this situation? If they're decomposing. We're decreasing. All right. 0 to 30. This is M number 14. All right. There's a closed interval, which means we might be doing theorems. The amount of grass clippings remaining is, all right, so A of t is equal to 6 point, this was a calculator one, 687 times 0.931 raised to the t, and this is measured in pounds. This is not a rate, okay? This is number of clippings in the bin at any point in time, t, and t is in days. Find the average rate of change of A over the interval 0 to 30. So you're going to need A of 0. You're going to need A of 30. So let's go to our calculators, and let's see how we're going to use these calculators to benefit us. The first thing we're going to do is we're going to go here, and we're going to type in 6.687. And then it's going to be times 0.9. Anything you put in your calculator, double check to make sure you've typed it right before you start to do any part of the problem. And that's going to be raised to the t. All right. And they said that we're on the interval 0. So I've got 0, but now I'm going to go over to 30. And I'm going to graph and see what I have. All right. Notice it's always decreasing. So I need to do A of 0, so I'm going to do second trace the Y generator, or the plug and chug is value. So I'm going to put in 0, maybe, there we go, 0, and at t equals 0, I'm going to have 6.687. Then I'm going to go back to my calculator, and I'm going to type in 30, and I'm going to know that my grass clippings at 30 is 0.78292787. So if I want to do this, then I'm going to do 0.7879, was that a 2? 2787 minus 6.687 all over 30 minus 0. And I will stop there because I know that that is, I've got it right, and that's going to be pounds per day. And did they say units? Indicate units of measure. So if you did this in the calculator, you should get negative 0.197 or 0.196. All right, find the value of A prime of 15. So if I want A prime of 15, I can still use my calculator. So we're going to go here, and when I do second trace, what am I going to choose this time if I want the derivative? You could have done, yeah, but you got to be careful, because if it said use, if it was a table and it said use data from the table, that would not have gotten you that point. But yes, you could have done A30 minus A0. So what are we going to use? 6. So we're going to do 6, and we're going to choose 15. And that is going to be, do I have a pen? Nope. So that is going to be negative 0.163 or 164. Now it says interpret the meaning. What does this mean? This means that the amount of grass clippings, because that's what it's about. Got to refer back to the problems. The amount of grass clippings in the bin is decreasing at a rate, not average, at a rate of 0.163. Why didn't I use the word or do negative? Because I used the word decreasing. is decreasing at a rate of, and that's going to be pounds per day, at a rate of 1.63 pounds per day. And we have to, but you're not done. At what? T equal 15, must include time. So you could have said I probably would have said at T equal 15, the amount of grass clippings in the bin is decreasing at a rate of this pounds per day, is how I would have worded it. Calculator error. And when you were doing the what? The derivative is we did the derivative 15. Is your window up to 15? Your maximum x, I put my maximum x at 30 because that's what my closed interval had said. And you do 6 and type in 15. What'd you get? Okay, so it was because your window. So when you have that and get that, then you go check your window. Part C is find the time which the amount of grass clippings in the bin, the amount of grass clippings in the bin, that's A of T, is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So A of T is equal to, what did we want? Average amount of grass clippings. Is that algebra 1 slope, or is that going to be average value integral? This is C. It is the integral, because this is grass clippings. And we want to know what's the average grass clipping. So since we're on the same level, we're going to have to do the average value. So since it's, that would be different. So now we're going to do, and this is going to be A of T. So dt. Now my window's at 30. If my window weren't at 0 to 30, this would be an issue. So now I'm going to go from second, and they just wanted average value. They didn't give us an initial one, did they? Okay. So I'm going to do 7, and that's going to be 0, 0. All right, and then I'm going to type in maybe 30. And I get 82.579. And I did not do that right. Okay, that's the average amount. What did they ask for? Am I answering the question? What did they ask for? Oh, I have to divide by 30. But they're asking not for the average amount. What are they asking for? The time. You with me? So I've got to get this first. So let's get the average value. So let's get the average value. Second, quit. I'm going to do 80. I should have done. Does the answer work? So if I do second answer divided by 30, what did I get? 2.752635. So now what I'm going to do is I'm going to come back to here, and I'm going to type that number here because I need that time. So 2.752635. I could have stored it and then done B. So now when I do this, I'm going to, now this doesn't look good. So do you see how the only way you can get rid of this shading is to go back and change a number. See, I just typed over 6 and the shading will be gone. All right, so now I'm going to do second trace. I want intersect, and all I have to do is be close to that point of intersection. Enter, enter, enter. It's not working. There we go. There we go. That's the time. The time is 12.4147. So if you got this You got 1 point. You got a second point for going back and finding t. So now it says for t greater than 30, L of t, the linear approximation to A at t equals 30 is a better model for the amount of grass clippings remaining in the bin. So we're going to use L of t to predict. So we need the linear approximation at 30. In other words, they're asking for the tangent line. At t equal 30. So do we have the slope at 30? I don't think so. So let's go back here and let's do second. Okay, so I'm going to go back here and I'm going to turn this off because I don't think I need it. Come on, move over. All right, so this is going to be, I'm going to do second trace. First of all, I'm going to get value. Did we get the value at 30 already? We did. Okay, so I'm going to do derivative. I'm going to do 6. And I want the derivative at 30. That is not 30. So that is at 30. Is it going to give it to me? Yes, it is. So I know that A prime of 30, the derivative at 30 is negative 0.0559762. So I think what I'm going to do is I'm going to store that, because I think I'm going to need to use that. I'm going to store that in alpha A. So there's my slope. All right. Now, I did my y value, my 30 up here. What was it? You see that 0.7? I think I'm going to go ahead and do that. So I'm going to, let's see. I'm going to take 7. No, it's point. I'm going to do maybe not, 0.787. 9, that was a 2. I didn't write a very good 2. 7, 8, 7. And I'm going to 7, 8, 7, 9, 2, 7, 8, 7. Yeah. But there still is a 7. Second insert, let me insert the 7. Oh, I just inserted a U. I didn't insert anything. So I need, okay, I'll type 7, 8, delete 7, and I'm going to store that in alpha B. Alpha B. Okay. So I'm going to let them know that this is B. So now my tangent line approximation would be y minus the y value at 30, which is B, is equal to slope, which is my A prime of 30, times x minus 30. Does that make sense? So now I need to predict at which point there will, okay, use this to predict the time at which there will be 0.5 pounds of grass clippings remaining. That means my y becomes 0.5. Minus b is equal to my a prime of 30 times x minus, or I should say t minus 30. That should have been a t. All right, so I'm solving for t. So this is multiplied, so I'm going to do 0.5 minus b. I'm dividing it by my a prime of 30. And then I'm going to add 30, so that should give it to me. So let's see if we can do this on the calculator. It's going to be 0.5. I'm going to subtract my b because I didn't use parentheses. I'm going to hit equals. From that, I'm going to divide it by alpha a because that was my slope. And then I'm going to add 30. Is there a plus? Plus 30. And when I add 30, I get 35 point, it should be 054. I think I did my y value. I didn't do a very good job copying my y value. That should have been 0.782928. So I didn't do my y value very good. But that's the idea. So I will be back here tomorrow. Same time, same place. And what do I need to do? I need to stop my video. So, you're welcome. Yes. And write down what I'm supposed to email because I've already forgotten. You want the answers to the multiple choice.